Everyone, greetings. I am Saksham and in today's video we are going to cover the exercise 9.3 of the chapter 9 circles from the grade 9 NCERT textbook. We are going to cover the question numbers 1 to 6. So let's start our video without any delay. So the first question of exercise 9.3 says that in figure 9.23. So we have given that this is the figure 9.23 in which A, B and C are 3 points on the circle with center O. Okay, so we have given that A, B and C are 3 points on a circle with the center O. This one is the center. Such that angle BOC is equal to 30 degree and angle AOB is equal to 60 degree. We have given that BOC is equal to 30 degree and AOB is 60 degree. If D is a point on the center of the circle other than the arc ABC, find angle ADC. So we have given that D is a point on the circle here other than this arc. Okay, so what is an arc? Arc is something that covers a region inside or outside the circle. So we have given that this arc. This one is an arc. Also, this one is an arc. So these are the arcs which cover the outside region of a circle. So we have to find the angle ADC. A, D and C. So we have to find this angle. Okay. So now we shall start solving the question. First we shall write the given information, which is that AOB is equal to 60 degree while BOC is equal to 30 degree. Okay, so now we shall write what we have to find. We have to find angle ADC. So we know that angle AOB plus angle BOC forms angle AOC. So we know that angle AOC is equal to angle AOB plus angle BOC. Angle AOB plus angle BOC. So angle AOC is equal to, we know that this angle AOC is equal to the sum of this angle and this angle. So AOB is what? 60 degrees and BOC is what? 30 degrees. So AOC will be equal to 90 degrees, which is a right angle. So we also know that angle ADC, which we have to find, is equal to half the angle AOC. Now where did that equation came from? This equation came from the theorem 9.2. So our theorem 9.2 states that this angle on a particular arc is equal to half of the angle situated on the center of the circle on which the angle is subtended by that particular arc. So we now know that angle ADC is equal to half times angle AOC. So what is angle AOC? 90 degree. So ADC is equal to half times 90 degree, which is 45 degree. So we have found the angle ADC. Now we shall move to the next question of the exercise 9.3. So the second question of exercise 9.3 says that a chord on a circle is equal to the radius of the circle. Find the angle subtended by the chord at a point on the major arc and also at the point on the minor arc. So we have given a circle in which we have given that the chord of the circle is equal to the radius of a circle. So first we shall draw the center. Let's mark this as center, which is O. Now we know that that the chord of a circle is equal to the radius of the circle. So first we shall mark the chord here. Let's mark this as AB. And now we shall join the center to each of the point of the chord. So we shall join it to the center And now we have a triangle in which there is a chord AB and two radiuses OA and OB. Now we have to find the angle on the point on a major arc and minor arc. So what is the major arc here? This one. And the minor arc? This one. So first we shall draw a point on the minor arc, which will be this. Let's mark this point as C. So we have to find this angle, also a point on the major arc, which will be this angle. Let's mark this as D. Okay, so now we shall start solving the question. We have given that chord is equal to radius, means that AB is equal to OA is equal to OB, is equal to OA is equal to OB. Why all these are equal? Because OA and OB are radius and the AB is equal to the radiuses of the circle. So what we have to find? We have to find angle ADB and angle ACB. Angle ADB and angle ACB. Okay, so to find these angles, we first have to find the angles in this triangle. We know that in this triangle AO and B, in triangle AO and B, this line segment is equal to this line segment is equal to this line segment, meaning all sides are equal. And we know that if in a triangle, if all of the sides are equal to each other, then that the triangle is an equilateral triangle. So we know that this triangle will be an equilateral triangle. So as this is an equilateral triangle, we also know that angle AOB, this angle AOB, angle AOB will be equal to 60 degree. Why? Because each angle in an equilateral triangle is equal to 60 degrees. Okay. So now we know that this angle is equal to 60 degrees. Now we shall find the angle ADB. We know that angle ADB will be equal to half angle AOB. Why? Because of the theorem 9.7. Angle ADB will be equal to half times AOB. AOB is 60 degrees, so it will be half times 60 degree, which will be equal to 30 degrees. So we know that angle AOB is equal to 30 degrees. Now we shall find the angle ACB. Okay, so we now know that angle ADB is equal to 30 degrees. Also, we know that this quadrilateral A, D, B and C, A, D, B and C, focus on this quadrilateral. This is a cyclic quadrilateral. Why? Because all of the points are lying on the circle itself. So we know that A, D, B, C is a cyclic quadrilateral. So we also know that this angle plus this angle will be equal to 180 degrees. Why? Angle ADB plus angle ACB will be equal to 180 degrees because opposite angles of a cyclic quadrilateral opposite angle of a cyclic quadrilateral sum up to 180 degrees. So this angle plus the opposite of this angle, which is this angle, sum up to 180 degrees. So angle ADB, what is angle ADB? 30 degrees. Plus angle ACB, what is angle ACB? We don't know because this is a unknown. We shall transpose this 30 degree to the RHS to make it minus 30 degrees. So this will become 180 degrees minus 30 degrees, which is equal to 150 degrees. So we know that angle ACB is equal to 150 degrees and angle ADB is equal to 30 degrees. So we have found both of these angles. Now we shall move to the next question of the exercise 9.3. So the third question of the exercise 9.3 says that in figure 9.24, angle PQR is equal to 100 degrees, where PQ and R are points on a circle with center O. PQ and R are points on a circle with center O. So we have to find angle OPR, this angle. So we know that first we shall write the given, which is angle PQR is equal to 100 degree, and we have to find angle OPR. So we know that this angle is equal to 2 times this angle because of the theorem 9.7. So what should we call this angle? This angle will be reflex of angle POR. So we know that reflex of angle POR is equal to 2 times angle PQR. Why? Because of theorem 9.7. So reflex angle POR is equal to 2 times PQR, which is 100 degrees. So this will be 200 degrees. Also this angle reflex angle POR plus angle POR is equal to 360 degree. Why? Because these two form a complete angle. Here we know that this angle plus this angle POR plus reflex of angle POR form a complete angle, and a complete angle is equal to 360 degrees. So we know that this reflex angle POR is 200 degrees plus angle POR is equal to 360 degrees. So angle POR is equal to 360 degree minus 200 degrees is equal to 160 degrees. So this angle will be 160 degrees. 160 degrees. Okay. So now, as we know that this angle is equal to 160 degrees, we also know that OP is equal to OR. OP is equal to OR. Why? Because these both are radius of the circle, and the radius of the circles are always equal to each other. So if these two sides are equal, then the angle opposite to them is also equal. So angle OPR is equal to angle ORP. Why? Opposite angles of equal side. These are equal sides and these are opposite angle to each other. So we shall let them to X. We shall let that angle OPR is equal to angle ORP is equal to angle X. So now we know that POR is equal to 160 degrees. So in triangle POR, POR. In triangle POR, this angle plus this angle plus this angle is equal to 180 degrees. Angle OPR plus angle ORP plus angle POR is equal to 180 degrees. Why? Because of the angle sum property of a triangle. What is angle OPR? This is X. This is also X. And this is 160 degrees. So we shall now transport this 160 degree to the RHS. So this becomes minus 160 degrees. And this x plus x become 2x. 2x is equal to 180 degree minus 160 degree, which is equal to 20 degrees. Now we shall transport this 2, which is multiply to the right hand side, so it becomes divide. So x is equal to 20 degree upon 2, which is 10 degrees. So x is equal to 10 degrees. So angle OPR is also equal to 10 degrees because we have let it to x. So we know that angle OPR is equal to 10 degrees. Now we shall move to the next question of the exercise 9.3. So the fourth question of exercise 9.3 says that in figure 9.25, this is the figure 9.25, angle ABC is equal to 69 degrees while angle ACB is equal to 31 degrees. We have to find angle BDC, this angle. So we shall first write the given information, which is angle ABC is equal to 69 degrees, angle ACB is equal to 31 degrees. We have to find angle BDC. So we know that this angle ABC, in this triangle ABC, this angle ABC plus angle ACB plus angle BAC is equal to 180 degrees. Why? Angle sum property. What is ABC? 69 degrees. ACB 31 degrees. Plus angle BAC is equal to 180 degrees. So we shall add these values, which is sum up to 100 degrees. Plus angle BAC is equal to 180 degrees. So angle BAC is equal to 180 degrees minus 100 degrees, which is 80 degrees. So as we know that angle BAC is equal to 80 degrees, we know that angle BDC is equal to angle BAC. Why? Because of same segment angle. These angles are in the same segment, which is the segment BADC. Okay, so these angles are in the same segment, so this angle will be equal to each other. So what is angle BDC? Is equal, this angle is equal to angle BAC, and angle BAC is equal to 80 degrees. So we know that angle BDC is also equal to 80 degrees. So we have now find the value of angle BDC. If you like this video, then I will recommend you to share it with your other friends. We will cover the rest of the question in the other two parts. Till then, stay tuned and take care.